Hi everyone, meet me again. From previous video, you have been learned how to determine deflection of beam using integration and Macaulay methods. In this video, I will explain about to determine the deflection of beam using moment area method. This method is different from previous methods. We start. The concept of moment area method provides semi-graphical technique for finding the slope and displacement that due to bending. There is advantages and disadvantages using this method. The advantages deals with the beams that subjected to series of loadings or having different moments of inertia. Meanwhile, the disadvantages can only be used to determine the angles or deviations between two tangents on the beam's elastic curve. To develop the moment area method, we will make the same assumptions we used for previous method. This method is based on two theorems. One is used to determine the slope and the other to determine the displacement. Here I explain about first theorem. As I mentioned before, one theorem is to determine the slope, or we can call the angle between any two tangents on the elastic curves. To derive the first theorem, consider a portion AB of an elastic curve of the deflected beam shown in this figure. The beam has a radius of curvature r. Figure here represents the bending moment of this portion. According to geometry, the length of the arc ds, of the radius r, subtending an angle d theta, is equal to the product of the radius of curvature and the angle subtend. Therefore, ds equals r d theta. Since ds is infinitesimal, because of the small lateral deflection of the beam that is allowed in engineering, it can be replaced by its horizontal projection dx. The angle theta between the tangents at A and B can thus be obtained by summing up the subtended angles by the infinitesimal length lying between these points. Thus, produce the equation. This equation is referred to as the first moment area theorem. The first moment area theorem states that the total change in slope between A and B is equal to the area of the bending moment diagram between these 2 points divided by the flexural rigidity EI. There are the rules for first theorem. 1. Theta B/A equals angle of the tangent B measured with respect to tangent A. 2. Angle is measured counterclockwise if M/EI diagram, positive, clockwise M/EI diagram, negative. 3. Theta B/A is measured in radian. This, for second moment area theorem, is to determine the displacement. This theorem is based on the relative deviation of tangents to elastic curves. This figure show the vertical deviation dt of tangent on each side of the differential element dx. The vertical deviation of the tangent at a point A on the elastic curve with respect to the tangent extended from another point B, equals the moment of the area under the M/I diagram between these 2 points A and B. This moment is computed about point A, where the vertical deviation Ta/B is to be determined. Since the centroid of an area is found from x bar, and the integration represents area under the M/EI diagram. Therefore, here is the equation to determine deflection. The rule for second theorem. 1. Ta/B is not equal to Tb/A. 2. The moment area under the M/EI diagram between A and B is calculated about point A to determine deviation Ta/B. 3. Calculated about point B to determine deviation Tb/A. Procedure analysis using moment area method. First is M/EI diagram. Sketch the free body diagram of the beam. Draw the M/EI diagram of the beam. This will look like the conventional bending moment diagram of the beam, if the beam is prismatic. Second is elastic curve. To determine the slope at any point, find the angle between a tangent passing the point, and a tangent passing through another point on the deflected curve. Since moment area theorems apply only between two tangents, attention should be given as to which tangents should be constructed, so that the angles or deviations between them will lead to the solution of the problem. The tangents at the supports should be considered. The beam usually has zero displacement and/or zero slope at the supports. The last procedure is moment area theorems. Apply first theorem to determine the angle between any two tangents on the elastic curve, and second theorem to determine the tangential deviation. A positive theta b/a represents a counterclockwise rotation of the tangent at b with respect to tangent at a, and a positive deviation t b/a indicates that point B on the elastic curve lies above the extended tangent from point A. Here is table for area and centroid of geometric shape. This table very useful, and we can calculate the slope and deflection based on the area of moment diagram. That all for now. We will continue next video example for moment area method. Thank you for watching.